Welcome back to the Rundown, interview edition. Today, I'm talking to Michael Hurlston, the CEO of Lumentum. Lumentum is a company that's caught the attention of investors. They design and manufacture optical components and high-performance lasers that allows for data to move at high speeds, and it's become a critical component of AI data centers. Business has surged over the last year, and so has the stock price, jumping over 1,000% in the last 12 months. So in today's conversation, we get into what Lumentum actually makes, why AI has been a game changer, the $2 billion investment from Nvidia, and some of the challenges of running a company in the middle of a boom cycle. This was a really insightful conversation. I think you guys are going to love it. So let's get into it. All right, guys, today we are talking to the CEO of Lumentum, Michael Hurlston. Michael, welcome to the Rundown.
Zaid, good to meet you. Really good to spend time on the show.
I'm super excited for today's conversation. I was doing a little research about you and your background. I realized that you took over as CEO of Lumentum February of 2025, so like 15 months ago. And I'm just curious, did you know you were signing up to be on a rocket ship when you took over, or was there a point after you took over where you knew like this is just going to be a wild ride?
You know, the board came in and they showed me a forecast, and I said, well, if that's the forecast. Of course, in my own mind, I derated it by 50% or so, and I said, well, if that's the forecast, it looks a lot better than what I'm currently facing in my old job. And I said, okay, let me sign up. Of course, it's not 2x, it's 4x what they said. So it's really been incredible. It's an incredible journey.
Well, I want to just zoom out a little bit and kind of learn more about the company. I think the company's become like a bit of a well-known company, especially in the investor space, because your stock has 10x since the last year or so. So can you explain in the simplest terms to someone who's not super technical what Lumentum does and why this AI infrastructure build out has been such a tailwind for the business?
Sure. So inside the data center, you've obviously got compute. We all know about that. The Nvidia GPUs, all these TPUs. You've got switches, right? Broadcom has done so very well on their switch portfolio. You've got storage. This is where Micron and these other names that you've covered in the past, again, have done so very well. But to connect all of those things, to connect the compute, to connect the switches, to connect the storage, you need connectivity of some variety or the other. And that's historically been Ethernet, just like you'd have in your office, your home. There's an Ethernet cable, a copper cable. But now that's switching because of the speeds, because of the bandwidth that needs to be carried. The world is switching from these Ethernet connections to optics. And what we do is we make fiber optic connectivity that goes inside the data center and forms all of these various connections.
So fiber has been a thing, for decades now. We have fiber, fiber in the street that right outside my house, fiber underneath the ocean. What is it about the AI data center build out that like requires fiber within the data center and close to the chip that you can't use copper anymore?
Yeah, first of all, you have it right. Our company has been around for 10, 12 years now. Fiber was the backbone of the internet. So if you remember back in the 2000s, we had this huge internet bubble, and fiber optics companies came in at that time to run fiber across the United States, and as you correctly said, across the ocean and things like that. What's new is the speeds at which we need to carry this data now are necessitating shorter and shorter distances. And it's those shorter distances that create a lot more volume and a lot more opportunity for the fiber optics companies. So we're used to these long haul applications where we might carry data over kilometers, over tens of kilometers. Now what we're talking about is meters. We're talking about 10 meters. We're talking about 5 meters. As things get faster and faster, copper has a natural resistance to it. Light doesn't. Nothing moves faster than light. And the only way to carry this amount of data, even at short distances now, is over fiber optics.
So it's because it's the large amount of data that makes the copper not as useful, whether it heats up or whatever the case may be. Is it because of the data? And before, with all the data centers, there wasn't enough data for where it was worth it or required to switch from copper to fiber. But now, with all the huge surge in AI compute and demand, you kind of have to make that switch to get like the best performance.
Yeah, you have it mostly right. One of the big issues, as you likely know, is the speed. So historically, data centers have run at 400 gigabits per second. That's kind of the connectivity speed when you're trying to connect a switch to a storage box, for example. Then it went to 800 gigabits per second. Now it's at 1.6 terabits per second. And that speed bump side is what is really what's driving this real big increase in the need for fiber. That's the issue.
Gotcha. And then speaking of Lumentum specifically, I guess I'm trying to understand like what is the technological moat here? Like, isn't fiber just like a commodity, or is there something that Lumentum makes, or is it the manufacturing or the development cycle that you guys have that makes you stand out compared to other fiber companies out there?
Yeah, the big thing is our lasers. So you have lasers that need to drive the fiber. The fiber is just glass at the
Hmm.
end of the day, right? As you likely know. And the light that travels across that fiber is driven by a laser. So our fundamental technology is lasers, and we've made lasers for years and years to what you just referred to, the long haul, when you have kilometers of distances and you're trying to rewire the United States, where you're trying to run fiber under the ocean. We've always had that kind of technology. But again, with these new speeds, and to your point, the amount of data that needs to be transmitted, you've got shorter and shorter runs. Those shorter and shorter runs now that are becoming fiber need to be driven by lasers, which is a simple light source that shines into the glass fiber. And that is where we have our competitive moat. The laser technology that we have is arguably second to none.
Gotcha, gotcha. So speaking of like the huge surge of demand, I mean, I'm just curious to see how are you guys dealing with the supply demand imbalance right now, right? Because there is a huge surge right now. That's not the issue. Demand's not the issue; it's the supply issue. So what are you guys doing right now to kind of catch up the supply? I think I read somewhere about you guys are increasing capacity at your plants in Tokyo. How do you think about like getting enough supply to meet the demand, but also being mindful of the fact that you don't want to overbuild in case the demand peters out at some point down the line?
It's a delicate balance to the last part of the question. It's definitely a tricky thing. These lasers are semiconductors, and we make these lasers in fab facilities. You've talked about on previous shows the semiconductor business, and
Yeah.
of course, a lot of the semiconductor companies are manufacturing at places like TSMC. In a small way, we are like a TSMC where we're fabricating these laser devices. And so it becomes a much trickier thing for us because we have to think multiple years ahead. In order for us to put a fab online, it's a 2 year journey from the day we say go to the day we actually see production units out of that fabrication facility. It's 2 years. So we have to think very, very carefully every time we want to bump up our capacity. These are not like TSMC. It's not the same order of magnitude when we think about CMOS semiconductor fabs. They're large, they have incredible amounts of capacity. In our industry, the material is indium phosphide, so it's a different kind of material, and that material is coming from much smaller fab houses. And so what we have to do is string together a good number of these to build up the capacity that we ultimately think that we're going to need in now 2028, 2029, 2030.
So there's like a upfront capex cost for you to build out these fabs. Are you fabbing them yourselves, or do you have like fab partners?
We fab them ourselves. What's a little bit different about these indium phosphide lasers is there's a marriage between the process, the fabrication process, and the actual design. It's if you think about a semiconductor, a CMOS semiconductor, TSMC is somewhat divorced from the person who's making a Broadcom and Nvidia. They can use what's called a physical design kit, a PDK, and that's a roadmap for them to design on the TSMC process. Our world is a little bit different. Our world is there's a really tight coupling between the design and the fabrication rules. And our designers have to work very, very much inside the fab. They work directly, they go inside, they look at what's happening in order to produce these laser devices, which, to an earlier question, creates that competitive moat. These are very, very difficult to design. And as such, it's very hard for people to come in from nowhere and produce a similar good.
What I'm curious about, though, so you have your fab, you're working on this. That requires some planning ahead of time, right? 2-3 years, because these fabs you can't pop them up overnight. But then the AI world is changing so fast. Right now, the hot thing is there's a shift from training to inference and agentic AI, and that's changing maybe the type of data center or chip required. And maybe we don't need as many big clusters of AI chips because inference doesn't require as much horsepower, just to use a common terminology. So do you think about that, like the fact that how fast this is changing? And maybe, I don't know, maybe we don't need as much fiber anymore because AI agents require less clusters.
Look, one of the points you're making is actually a really interesting one. What we've seen is kind of the politics of the data center. There's three aspects that go into it. One is the one you just touched on, sort of the inferencing and how much compute is needed around inferencing. The second is power, right? You've got this huge power draw. And third is a little bit of the politics of data centers. People are worried about how these massive build outs are going to affect their bills. And so what's happening is you're seeing smaller and smaller, more modular data centers get built out, data centers that are perfect for that inferencing type of application that you just mentioned. And then what happens is you've got a network in a similar way that you were networking the internet. You have to network these data centers themselves together. That's what we call scale across. Scale across means I'm running one data center, networking it with another at full rate, at full bandwidth. And again, that's great for our products. We make and service this whole concept of scale across, and we enable data centers to talk to one another at full rate. It goes back a little bit to our old business, which was creating the internet, the backbone for the internet. Very, very similar type of technology.
So what you're saying is, instead of having one giant data center where the community is going to be upset, and we've already seen some of that, happen politically, some of these companies are starting to make smaller data centers with smaller footprints. It's not as loud, and in order to make it efficient and still kind of work together, you have to connect them with fiber and the things that you guys provide.
Exactly. Yeah.
Gotcha.
So there's been a big push to these smaller data centers, both for power and for politics, and it's really helped our business, a different aspect of our business, but it's helped our business out quite a bit.
I want to talk about the data center build out. A lot of the money being spent to build out these data centers is coming from just a handful of companies. So you have the hyperscalers, obviously Google, Meta, Amazon, Microsoft, and I think it's all of them. But do you worry about the customer concentration risk, or is that just the game at this point?
I think it's the game at this point. Yes, it is very concentrated. You're 100% right that there's 5 or 6 companies that are really driving the infrastructure build out. And great news for us is we're working with all of them. These laser chips that are fundamental to our business are running in Amazon data centers, are running in Microsoft, they're running in Google, they're running in Nvidia. So we really have a breadth of customers, given the fact that it is so very concentrated. It's a concern. Nobody likes to see 5 or 6 guys driving the entire market, but at this point, there's not much we can do about it.
And So far, there's no signs that there's a slowdown coming anytime soon. I mean, all we hear is that we're compute constraint, compute constraint. I mean, Anthropic just did a deal with SpaceX to get more compute. So it doesn't seem like there's a slowdown anytime soon. But I just try to think about like at some point there's going to be a supply demand balance that happens, and then what then? And I'm just curious to get your take on your side. Like, what does it look like 5 years from now?
Yeah, look, I mean, it's an interesting question. For us, we see no end in sight for the next 5 years, but we have this very interesting phenomenon that's happening in our industry, and obviously our company is the leading company in optics, and that is outside of sort of this hyper growth of AI. Given what we talked about in the first part of the conversation, this shift in speed, this increase in speed, you're having a steady increase of optical content inside the data center. So let's just say for a minute that in 2030 the build outs do slow, that we don't see the number of data centers get installed. We still have growth in front of us just given the speeds that we see. It's going to be a kind of a steady march where more and more of the connections are going to be fiber optic rather than that Ethernet copper cable that we talked about a minute ago.
Gotcha. That makes sense. I want to go back in just a second. You mentioned that Nvidia is a customer of yours. They're also an investor. They recently announced that they invested, I believe it was $2 billion into Lumentum. And Jensen talked about building gigawatt scale AI factories with you guys. Can you just talk more about that deal? And was Jensen wearing his iconic leather jacket when you sat down to meet with him?
Look, I think the important thing for us, everybody's talked about that investment, and it is important. But the more important thing was the purchase commitment that they gave to us, which was a multi-billion-dollar purchase commitment. They see exactly what we've been discussing in this conversation. They see a shift from Ethernet, from copper toward fiber optics. The copper industry, frankly, is super well built out. There's a lot of great companies that can supply Ethernet transceivers, Ethernet type of products. So copper is a pretty well oiled machine when you think about that as an industry. What we have here is a very small industry, quite frankly, around fiber optics. It's growing like crazy. As you correctly said at the beginning, our stock has obviously performed well. There's a lot of companies in the sector, frankly, that have done very, very well. But the issue is the industry is small. And what Nvidia was worried about, I think, was, look, there's a finite amount of these indium phosphide lasers. We need to get to the front of the line as quickly as we can. And they not only did a deal with us, they did a deal with one of our competitors, another person in this industry. And I think between the two of us, they've done a good job of cornering this indium phosphide market. And that's put pressure on other folks who have to make the same shift from copper to fiber optics. That's put pressure on them to think about how they're going to get capacity in line.
You mentioned how the stock has done really well. Do you ever just think about like, how everyone's likes to bring up the AI bubble conversation, and especially with fiber, we kind of went through this in the 90s and early 2000s where we literally had a fiber bubble and then it popped and a bunch of companies unfortunately didn't make it. Do you just think about like, okay, maybe this is going up a little too fast and you might have to set expectations properly? Or do you just feel like this time it's going to be different?
Those are dangerous words.
Yeah, I know.
Right? This time is different. Those are dangerous words. Look, this company was in the middle of that bubble that you just talked about. Lumentum is a spin-off of JDS Uniphase. JDS Uniphase was a poster child in that run-up, and they saw one of the great stock appreciations, and then it crashed to a single-digit, almost a penny stock before it was able to resuscitate, and we were spun out from the ashes of that company. What is different, if there is a difference, is who's spending the money. You had in 2000, you had the telcos, AT&T,
Right,
Telefonica, Deutsche Telekom, British Telecom. It was other companies in Europe, in China, in the United States, sort of spending the money. those are not well-capitalized companies. They're not companies that have deep pockets. What we're seeing here, obviously, is the hyperscalers, companies like Amazon, Meta, the best companies in the world who do have deep pockets, who are willing to spend and feel like this AI arms race is something they can't lose. And so what you see is a tremendous amount of spending by companies that can spend the money, who are involved in a battle that they feel like is a must win. So I think that's the difference. Look, I think the growth rate is going to have to slow eventually, right? You're going to have some of these folks are going to win, some of them are going to lose, and you're going to have even a higher customer concentration, which will slow down the build outs. But I don't think that happens for the foreseeable future. As I said, our forecast now is extending out 4 and 5 years, and we don't think that this thing slows down for quite some time.
That's incredible. I mean, as someone who watches the markets and has just been watching this for the last few years, it's just been incredible to see and just the different phases that we're going through. And it's just the fact that it changes so fast is what like just keeps me on my toes. Cause like, I mean, nobody was talking about AI agents a year ago, and now everyone's talking about AI agents. I'm like, what's the next thing going to be, Michael? Like, what's the next thing that everyone's going to be talking about that everyone's going to have to adjust to as investors?
Look, I think the big thing in our area is something we call co-packaged optics. So today, these fiber connections are run. There's something that looks like a pluggable, like almost like a USB stick that you put in your computer. There's a little USB drive that goes in the back of these server elements, the storage elements, the switch elements, and creates that fiber optic connection. Fiber or optical, I should say, is becoming so ubiquitous now that more and more companies are talking about putting that optical engine actually on the board, maybe even inside the package with the silicon. Jensen, who has been a great partner of ours, last year at GTC talked about what he refers to as a CPO switch, a co-packaged optic switch, meaning the optical engine now has moved inside that box, inside the rack, and much closer to his switch chip. And that really is enabling power savings. It's enabling the additional speed and bandwidth benefits. So our industry is going through a whole renaissance where, as I said a minute ago, you've got a bunch of things that are sort of playing to our advantage. You've got this whole copper to fiber transition. You've got a pluggable to a CPO or near packaged NPO transition. All of these things are working to our favor, and it's just going to get faster and faster. I mean, we know that if you follow the semiconductor industry, you have famous Moore's law. Speeds get ever faster, and that really is playing to the optical industry's advantage.
Yeah, it does feel like we're still in the early innings, and I mean, I can't wait to see where it goes from here. I know you guys are at the forefront of this stuff too. So congrats on everything you guys are doing, and I appreciate your time, Michael. And hopefully we'll get you back on in a year or so. We'll be talking about the latest innovation that Lumentum is doing, and maybe we'll do a trip out to Japan and take a tour of your fab out there.
We don't even have to go that far. We can just run over to North Carolina and check out our latest addition to the family that we announced a couple months back. So love to have you, Zaid. Anytime.
I'm in.
Anytime. Seriously, we'd love to have you.
I'll meet you in North Carolina next time. I appreciate it, Michael. Thanks so much.
Perfect.
All righty. Well, all right, guys. Hope you enjoyed that conversation with Michael Hurlston. I learned a lot talking to him, like the fact that Lumentum manufactures their own components and have their own fabs, which I didn't know about. And that paints a picture of how challenging it is for them to scale up supply because, opening a fab isn't something that can happen overnight. So I'm really curious to see how they're going to handle this boom right now when it comes to the AI build out. Personally, I am a bit nervous about valuation. The stock has already gone up 10x in the last year, and it's currently trading around 55 times forward earnings, which is kind of rich, and a lot of that hype and growth is already baked in. But look, Wall Street analysts are still pretty bullish right now with the average price target of $1,100, with some price targets as high as $1,400. Let me know what you guys think. Are you still bullish on Lumentum? What did you think about the conversation? Drop your thoughts on Spotify and YouTube. And while you're at it, consider giving us a 5-star rating as well All that engagement really does help us out, and it helps other people find the show. And just FYI, in case you're new here, we post a new episode every single day breaking down what's happening in the market. So if you're interested in that, consider subscribing to the podcast. Thank you guys so much for listening, watching, and commenting. Shout out to Mike for all the work behind the scenes. And we'll see you guys back here tomorrow.